We're going to look at more quadratic functions today, and we've already looked at quadratic functions that have an a value and a k value, but now we're going to look at quadratic functions that also have an h value. So to review, whenever we add a constant, which is add a constant to our quadratic, our x squared, if our constant is positive, then the graph is going to slide up that many units. If our constant is negative, the graph is going to slide down that many units. And then the vertex changes to 0, comma, whatever that constant number is. And remember, the vertex is that point where the parabola turns. So it's going to go into the vertex, and then it's going to go the other direction. Or if it's going downwards, it's going to go up, and then at the vertex, then it goes back down. So that would be your vertex, 0, comma, whatever that constant number is, which we typically call k. Now, when we add a middle term, we're going to have another translation. And we can see this translation better if we write it in this form. We call this the vertex form. We have f of x equals a times x minus h squared plus k. So notice that there is a minus right here. So if there is not subtraction right here, you have to rewrite this expression or manipulate it to where we do have a subtraction right there. That constant h has to be subtracted from the independent variable before you have your squared. So just make sure that this is the correct, that everything is in the correct form before you begin anything. Again, this is called vertex form. So let's look at an example. We want to find the x-coordinate of the parabola's vertex and then solve. So for example number 1, our original graph is g of x equals x minus 3 squared. So in order for us to figure out the x-coordinate of the parabola's vertex, we need to set the inside of the square, the x minus 3, equal to 0, and then we are going to solve. So that means x is equal to 3. So the x-coordinate of the vertex is 3. And since there is no k value, that means that your y-coordinate would be 0. So to finish graphing, we can make a table of ordered pairs, including x equals 3, and then several points on either side of 3. So you might do 1, 2, 3, 4, 5, something like that. So make sure you have points on both sides of the 3. So here's our table. When we plug it into our function, these are the results that we get, the y's that we get. So again, here is our x equals 3 and y equals 0. So this is our vertex right here, 3, 0. So each point of this function g of x is going to be 3 units to the right of our parent function x squared. So here's our parent function x squared, and when we graph those points that we got on the table, it ends up being that everything is translated 3 to the right. Okay. Next example, we're going to do the same thing. So this one says h of x equals x plus 1 squared. So the first thing we want to do is find the x-coordinate of the vertex. So to do that, we have to take that x plus 1 instead of equal to 0, solve for x, and x is equal to negative 1. So we know that the x-coordinate is negative 1 for the vertex. We'll make a table of ordered pairs, doing negative 1 and then do 2 before negative 1 and do 2 after negative 1. So here's our table. We'll go ahead and evaluate to find our y's. Alright, so remember, negative 1 is the x-coordinate of our vertex. So when we plug that in to find our y-coordinate, and our y-coordinate is 0, which means that our vertex is at negative 1, 0. So when you graph your parabola, the turning point should be at negative 1, 0. So when we compare this function h of x to the parent function, f of x, which is x squared, we notice that everything is left of our parent function, right? Everything moved left. So we could say that the graph of h of x, which was the x plus 1 squared, is a result of translating the parent function, f of x equals x squared, 1 unit to the left. All right, so let's take a second to talk about translations. When we have the graph of f of x equals ax squared, you're going to translate it horizontally whenever you're looking at h. Okay, so whenever you have a constant h that is being subtracted from the variable before the variable is being squared, then that translation is horizontal. So if you have the graph of f of x equals a times x minus h squared, so again, the h is being subtracted before it's being squared. So one more time, the h has to be subtracted before squared. So if you have this graph in this form, it's going to go right if h is greater than 0, and if it's going to go left if h is less than 0. Only if it's being subtracted from x. So if you put a k value or a constant after the square, then that's going to combine a horizontal and vertical translation, because the h translates it horizontally and the k translates it vertically. So if we want to graph this function, p of x, which is x minus 2 squared minus 1, we have an h translation here, and we have a k translation here. So the x-coordinate of our vertex is going to be 2, because x minus 2 equals 0, which means x is equal to 2. And then our vertex, our y value, will be negative 1, because our k value is negative 1. So that means our vertex is 2, negative 1. And then comparing that to our parent function, x squared, if our vertex went from 0, 0 to 2, 1, that means it went 2 units to the right and then 1 unit down. Okay, if we are looking at this vertex form, a of x minus h squared plus k, if x is equal to h, that means we can plug h in for x. That means h minus h is 0, which means that f of h is k. So therefore, we can say that the vertex of this form of our function is always going to be hk. Okay, so anytime that you have a function in this form, your vertex is always going to be h, comma, k. Be wary though, if your h is not being subtracted from the x, you have to manipulate it first before you can state what your h is. And then also we have a line of symmetry, and the line of symmetry is going to be that vertical line through the vertex that the parabola is being reflected across, right? So the line of symmetry is always going to be a vertical line, which means it's going to be x equals something, and it's actually going to be x equals h. It's always going to be your x coordinate. So your line of symmetry, which is a vertical line, is going to be x equals h. So for our next example, we want to graph q of x, which is negative 2 times x minus 3 squared plus 5. So for this graph, our vertex would be at 3, 5, because our x-coordinate is 3 and our y-coordinate is 5. Our h is 3 and our y is 5. And then our line of symmetry would be x equals 3 because our h is 3. If we made a table of ordered pairs for this function, we can get some points. And then once we can sketch the curve. This form of the quadratic function is called the vertex form or the graphing form because it has all this information about the graph of the function. So if we have this f of x equals negative 1/3 x plus 7 squared plus 9, you'll notice that it's x plus 7, but remember the h has to be subtracted. So we have to manipulate x plus 7 so that way it is a subtraction problem. So remember, subtraction can be defined as addition. Subtraction is adding the opposite. So I can rewrite x plus 7 as x minus negative 7, and it's still the same expression. And so now I have rewritten it as x minus negative 7, which means my h value is actually negative 7. Now I know that my vertex is negative 7, 9, because h is negative 7 and k is 9. And my line of symmetry will be x equals negative 7 because my h value is negative 7. And then we also know that this graph is going to open down, and we know that it's going to open down because our a value is negative. We also know that it's going to be flatter than our parent function, and we know that it's going to be flatter than our parent function because we have 1/3, which is less than 1. Alright, so let's look at this example. We have x squared minus 6x plus 10. So this is not in our vertex form. So what we can do is we can complete the square. And when we complete the square, we take half of that b value, which is 3, and we square it, and that's 9. But if we add 9, we have to make up for that 9 on the outside. So if we add 9, then we will subtract 9. And then now that we've completed this square, this becomes a perfect square. So this x squared minus 6x plus 9 becomes x minus 3 squared. And then we'll go ahead and simplify this. 10 minus 9 becomes 1. Now this is in vertex form, which we can identify the vertex in the line of symmetry. So your vertex, your h value is 3, your k value is 1. Your a value is 1, which means it opens up like the parent function. So it's going to open upward, and the vertex is at 3, 1. So if you look on page 518 of your textbook, they have a little formula on how to calculate your h and your k if it's not in this form. So you can manipulate it to look like this form by completing the square. Another option is if you use this formula. Your first formula is that your h value is going to be equal to negative b over 2a, and your k value is going to be c minus b squared over 4a. So let's look at an example doing that. So here is your quadratic function. You have negative 2x squared minus 12x minus 19. Now, you could complete the square and then and manipulate this to look like your vertex form, or you can use those formulas that are found on page 518. So first we have to identify our a, b, and c. Our a is negative 2, our b is negative 12, and c would be negative 19. And then remember the formula for h is going to be negative b over 2 times a. So because our b was negative 12, we'll put negative 12 here over 2 times negative 2, since our a is negative 2. We'll go ahead and simplify that, and then we end up with negative 12 over 4, which is negative 3. So we know our h is negative 3. So our k is going to be whatever we get when we plug in negative 3 for x, right? So if we plug negative 3 into this function, we would have negative 2 times negative 3 squared minus 12 times negative 3 minus 19. So when we evaluate that following order of operations, it simplifies to negative 1. So now we know our k value is negative 1. Now that we know what our h and k value is, say that our vertex is negative 3, negative 1, and the line of symmetry is x equals negative 3. Since our a value was negative 2, we know that the parabola will open downwards.